Hello and welcome back to compiler programming. In between the videos, I did a small cleanup, and in particular what I did is I changed all the functions to return a pointer to the value instead of like value on the stack, because it is necessary for what we will be doing today. And as a part of that refactoring, I also introduced this function called temp allocate, which is a handy thing that I use in other projects as well. Basically, the way it works is I have a buffer defined as a global, and that buffer, let me show you. Yeah, and then I just kind of use that buffer as a memory arena to get pieces of memory instead of calling malloc. The reason this is handy is because, first of all, this type of allocation is much faster. It's also called bump allocator, because if you look at the implementation of what it's doing, it literally just adds this assertion that will be even compiled away in release, and then it adds the size of the so kind of moves the pointer or bumps the pointer. This is why, hence the name, bump allocator, and that's it. While malloc actually does a lot of lookups internally to figure out where exactly to put stuff in memory, because it tries to be efficient and allows for freeing the memory, while this type of allocator usually does not really is not designed for freeing memory. You're just always adding, and then you're resetting it in bulk. For us, that bulk is happening when we run a new test. So at the very start of the tests here, so before all the tests run, I create this 1 megabyte temporary buffer. And then before each test, I just kind of reset the pointer and start allocating again from the start of the buffer. This can grow later. You can also, like if you have an application, for example, that is not like a compiler that is just one pass over the files, but something more interactive where you have an event loop, then you would, for example, do this reset on each event loop, and that way you have very fast allocation for temporary values that you might need during that event loop processing. So this is just a very handy pattern that I really like. Okay, anyway, the main topic for today is trying to make all of these a bit more readable, because while all of this does work, it's not exactly pretty. And if I look at our usage code, and this is what I want to focus on today. So for example, this function would be nice if it was reading a lot more like C code. And in particular, the way I imagine this is to use C macros to help us capture this idiom into something nicer. So what would it look like? Ideally, I think I want something like this. It's going to be, say, we'll have a function macro, and inside the function macro, I just say the name of the function, and let's just say constant, or function result in this case, right? And then I would do something like this, and whatever is inside the function is the function body. Okay, now I also would like to have return as another macro, and just say value from S32. I think this is okay. We could later maybe even turn this as something like this, S32 of integer, This could be fine, but for now, value from S32 is okay for me. It's readable enough. Okay, and actually, since I'm using C99, it does, I think, allow overloading of macros based on types, but this is not something I looked into, so I will not try to go for this today. Okay, so this is what I would like to have, right? And this reads pretty naturally compared even to this version. So let's try to just make that happen. We obviously need a function macro, and macro that will accept the ID of the function. And what it will do is it will create a value that is going to be called this ID that will start as an empty pointer. Then we will do that trick that we did before with if. Let me find this definition. So yeah, this is basically for loop trick. Define function. Okay. So this is roughly what we want. Obviously, we don't want patch, and we will not even need the dummy value, because instead of dummy value, we will now have this ID that we can use to figure out if we should exit the loop or not. So we just say if not ID. Okay. And as the beginning of the loop, it's quite naturally fits. We just create the function builder. And at the end of the loop, we say ID is function end of builder. We can even be nicer and do something like builder ID, so that we don't accident, like if we have nested ones of these, they will be different from each other, so we don't accidentally do the wrong one. And I will add another pair of braces. With macros, you can never have enough braces, so that's good. Okay, that sounds like it might even work. And the last one is we need return. And return is actually going to be a bit trickier, because in this case, it's fine to be, we can just basically take this stuff and put it in the define. But as we will see later on, we will need to potentially do this jump to the epilogue of the function that does the stack restoration to the right place and restoration of registers if necessary. And this will require a bit more wiring, but still, this is the end API that we want. Okay. Anyhow, we say that we want to return a value, and returning a value literally means this. Actually, now we do run into a small issue that we will unfortunately have to name this builder, or I will name it builder underscore, because I don't use names with underscore as names in my regular programs. And basically, we implicitly expect return to be always used inside of the function. And function defines this builder thing. Okay, so let's see how we are doing. We are actually building, so I didn't even mess up anything. Let's see what we have as tests, and it works. Great. So this, I think, is good enough progress. And even more so, I think it is good enough for us to completely get rid of make constant, because it just adds unnecessary overhead and unnecessary call. This is almost as nice as just calling this function. So we will just copy this, get rid of the function, and search for where it was used. Okay, so now we put it here and say like so, and I believe we also use it in here. Yes, so we have another function here. Let's see, integer undeclared identifier. Yes, it should be 42 and 42. Great. So now we actually have a very nice start. Let's check that it all still works. Indeed it does. So let's add it to index and continue working on the next function and see if it's also as easy as the previous one. Okay, now we have make identity. I already know what to do with this. We say function result or ID and return ID. And inside, now we need another helper. So obviously we can keep it like so, but I would like to have something better. So we'll create an arg helper, and arg will expect a descriptor and an ID. And it will do just this. Right? So now we can have value ID, and descriptor goes into here with an extra set of braces. Okay, so now we say arg x descriptor s64 and return return x. So let's see if this is at all what we had before. And it still works. Great. So the same thing. I don't think we need this make identity s64 function anymore. But before we jump into that, I think I want helpers that are even nicer to not have to do this and just have type predefined for simple things, because it's just in general a bit nicer. And we will probably need one for S32 as well. So now we can say arg S64 of x and return x. This looks pretty nice. Obviously, we cannot make it really one-to-one, or at least it's going to be very, very hard to make it one-to-one with what C looks like. But still, this is the code that anybody that knows C-like languages and is aware of this quirk with how we define argument can read, right? So this is a big thing. Now I can get rid of this, say make identity, and we put it in here, and in here, and in here. Something did not work out, so what is that? Line 553. So currently we're using identity in another place, which is fine. We'll just put it here as well. And we need ID. Cool. So let's run another set of tests. Everything is great. Stage the stuff and let's continue. Where were we? We were right here. So this is a bit more complicated function, and I think this is the one that actually is gonna even show better why we're doing this. So we say function increment. Now we also want to have the same as with arg. We want to have one for stack, right? We want to have stack ID and descriptor, and we say reserve stack descriptor. And actually this arg-s32 can use arg internally so that it is so we don't repeat ourselves with the way we specify this. Let's try it this way and this way. Okay, this should be 64. Okay, I like this better, yes. And we can do the same thing for the stack, right? So we can say stack s32, stack s64 is going to be stack. Sounds great. Okay, so now that we have this these nice helpers, we can make use of them. We can say stack s64 of x, stack x64 of y, and it would be nice to add arguments. Actually, like sort of we have to put arguments before any of the stack things, because arguments will define where this the stack variable actually starts. Right now we only have 4 arguments maximum, and they're all passed in registers. They're all maximum 8 bytes, but later on this is going to change, so we'll probably need to have an additional check that kind of tracks this stuff, that we don't try to allocate stack stuff before we get all the arguments in. But this is not for now. I could write to do add a check that all arguments are defined before stack variables. And this is something we can totally do. We can add on the builder like a flag saying, okay, did we if we're trying to get an argument after some stack was allocated, then this is a no-go. Okay. So we need an argument, which is an s64. So we can say arg s64 is, I don't know. Let's call this actually 1 and 2. And this one will be x. And now we say, ideally what I want to say now is this, right? We just say plus. And for now, I will just put this builder here, but I will create a helper for the plus as well. So this is just temporary for us to make it all work. So we say plus builder x1, and then, or actually not 1, here will be minus builder 1 or 2, 1. I don't need this, I guess. Yes. So it should be something like this. Okay, that looks like what we want. And now it reads much better. Let's define these plus and minus helpers as well. So plus a b. It's very straightforward. It's just plus of builder, then a, and then b. And now we can replace this here. We can do the same thing for minus. And we can probably add right away multiply and divide. Multiply, divide. That seems nice. Let's make a use of our minus in here. And this is very nice. It's a weird mixture of, I guess, something like Lisp and C or even assembly, but I think it's still very, very neat. Of course, only if that works. Syntax missing. You're right. I am missing stuff. And here I need to not do this. This is a bad thing to have in macro. Like ideally, this kind of macros should not have semicolons, and you put semicolon yourself. Let's try that one. Still doesn't work because we don't return increment. Okay, that does build. Let's run the tests. Oh, tests fail. Okay. Did I do that correctly? So we do two. Oh, yeah. I did define a stack value, but I did not initialize it. And I guess this is actually an interesting question. Do I want to initialize? I believe I always want to initialize a stack value. It's a general good practice. And if we want an initialized version, then we will do that later. So what I will do is now say ID, or actually we want to move, so we want to use our assign function, which we also need to fix. Yeah, let's do this as a separate pass. For now, I will do this manually and use. Actually, we can use assign. This is fine. So let's just say value. Then we say ID assign builder ID operand and this will be assigned to a value. Okay. Actually, right now it should be value operand, but we definitely need to change assign to take values instead of operands directly. For now, this is not really important, and we can continue with saying value from S32 1. Okay. Let's check, and this should be 2. Let's see if that builds. Something is not exactly right. We want slash here. Still not great. Am I missing a brace? Too many arguments for function like macro. Oh yeah. Now we need to pass on this here as well. Great. Let's try this out again. And now it works. Great. Good. So we can get rid of all of this stuff. And I think in the same manner, we will stop using make increment function and instead inline this into the test. So where was our make increment? It's here. We this like this. And it builds, it runs, and we are one step closer to victory. What do we have next? Call function value is actually just a helper, and we will definitely need to add a wrapper around it as well. But this one is going to be tricky because adding a wrapper for this will require variadic macros, and defining variadic macros is always a bit finicky. So let's leave it till last, if we even do it today. Okay, this should actually be temp allocate and not malloc. I guess I missed one. Yes, that's fine. Okay, make call no argument return S32. So how do we do this one? Well, let's think about it. I think when we did this, our return did not even do the right thing. Let me consider this for a moment. So I believe this function is sort of wrong. It should accept a a value here. So I will not fix it for now, but accept a function to call as an argument, because then these returns would be just the returns of the function that we accept, and we will not have to create this here. This is not what we are doing right now, so let's just continue with result. Function call, or call is a bad name because we have a global named call. Call no arg, or unimaginatively result, and return result. Okay, what do we have here? Yeah, we definitely need to to do this. Maybe we should. Let's just make that happen. But I guess one refactoring at a time. So let's start with actually accepting a value star function to call. And this function to call now is super easy for us to do, because these should go there, and in here what we have is function to call. Actually, we do need this ampersand function to call descriptor. That's good. And now we are just calling that function. So that's fine. It will obviously break because we don't have this stuff here. But this is fine. We can probably replace it with something better. Actually, we even have the function right here. So this seems pretty handy. Don't know if I broke anything. I didn't. And now it's even nicer than it was before. We just create this function like this and pass it to another one. It's almost like we have a high-level language, even more high-level than C. Okay, so all of this goes away, which is great. And now we can get back to original refactoring that we were doing. And that refactoring now is also super simple. Arg function, and here I will need to specify descriptor explicitly, but I think that's okay for this complicated version. And we just do return of this stuff. Call function value, and again, this should be replaced to do create variadic macro for call function value. Maybe we should add this to do here, right? But for now, that's fine. Let's remove all of that. Check how is our stuff. I'm missing a colon, and arg0 is undefined. Yes, now it's called function. That's great. Let's try this out. It all works perfectly, and since again out of a very large function, we now have these 4 lines. So make call no argument also goes away. Make call no argument. So This is pretty neat. We can call it color like it was before. Oops, wrong button. And we just say like this. And look at that. I think this is super nice because this actually reads like like a regular program. Imagine that you don't have any of this stuff around, and this is just the program that you have at the top level. This is sort of very similar to what you would write in a language, a pretty awkward language, but language nonetheless. Good. So let's remove this white space. We don't need it. Now on to the next thing. We have make partial application. Okay, what is that gonna look like? I think this is gonna be even easier than the previous one. So we say function partial is this, and partial. So we want what? I guess we want to say return and this call, right? And then this all goes away. We have to say builder underscore. Again, our call to function value will need some adjustment, but not right now. Right now we are doing different cleanup. All the tests still pass. Again, it looks like it's easier to just get rid of this and then search for make partial. This is what we want. And we can put in ID into here. And we remove partial function value, put this into here, test it out, find that we did something wrong. Yeah, it should be value from 6442. That's great. Apparently I messed up something elsewhere. Oh, how did that happen? I think it's supposed to be like this. Yeah, I don't know how that happened. Everything still works, which is great news for us. Okay, so with our little macro language, we were able to significantly shorten all this stuff, and now only the tough things remain. I think I will leave out the variadic macro for another time for calls, but I wanted to still do this today because I still have a bit of time. So let's do that. Function is non-zero, and then we say arg s32 x unimaginatively. Now we say this, right? So we do if equals x value from s32 0. Then we do return. Okay. And we don't need the builder. So for now, I will keep this return patch around because first I want to convert just what we have here and only then introduce new functionality, which is going to be somehow tracking these return patches. Okay. If this, otherwise we say return value from S32 1. And yes, we need this patch jump to here, which is a bit unfortunate, and we will get rid of it shortly. Okay. Now we say return is non-zero. What is wrong here? Builder undeclared identifier. Oh, this is definitely true. Because now this is called builder underscore. That's good. And I think we also need to change if to be builder underscore. Okay. Unexpected end of file in macro expansion. Yikes. Yeah. But it is correct. Patch jump to here of builder. Builder. Undeclared identifier. Are you sure? I'm confused a bit. Oh, yeah. This is one of the big ones that we still have to do. And here we unfortunately also have to change builder to underscore. Otherwise our ifs will not work as they should. Builder. Okay. And we also have builder here, and builder here. Good. Where were we? We were in make is non-zero. Test. Okay, everything is fine. And now we are ready to start working on the return. Okay, so how shall we do this? Basically, inside the builder, we'll now need some kind of storage that keeps track of all the returns and patches jump to the end of the function. And there is a probably optimized version of this where we don't do the jump if we are already at the end, but for now I will just completely ignore this stuff and just do a jump that jumps by 0 essentially, which is fine. I think it's not even a big deal for CPU. It will probably be optimized the way anyway by the CPU frontend. So anyway, this is all good, but where is our function builder? It's all the way up here. Okay, how shall we do it? I think the easiest thing would be to create a linked list of these returns. So let's do type def struct. We'll call it function return patch, and what it will have is we need to now move patch 32 a bit up. Yeah, this should now go to here. So it will contain a patch 32, I guess. Yeah. patch, and then it also contains pointer to the next. So we'll need to do this way to define this and say struct function return patch next. Okay. So we are putting these into the builder and say return patch list. That's good. Now we can go to our function start. Did I call it begin? Yeah, it's called begin. So we also now need to say return patch list is 0. This is 0. That's good. And when we do end, we have to do some funky stuff. So this is overriding stack reservation. This is good. This is already, yeah, this is overriding the reservation, which we can also actually now do as a patch 32 if we wanted to. That also could work. But this is not what we're doing right now. So let's continue our return thing. And the idea is every time we do return, we will push value to that list we just created. And then in here, we will do the jump to the right thing and update all of them. So we say while builder return, or actually we should do it this way. Function builder, or what did I call it? I already forgot what I called it. No, just a minute ago. It's called function return patch. Okay. Function return patch star patch list, and we say it's like this. While we have this, we say return patch is return patch next. And here we need to actually do the patch, which means we might need to move up this stuff around jumps a bit to the top. So let's put it before our function stuff, right around here. That's good. And we need patch jump to here. So for all of these, we patch jump to here, return patch. Let's check that this compiles. Patch jump to here needs builder, I guess. Yes. Okay, this compiles, but it will blow up horribly if we try to actually do this. So let's actually do the other side of the equation. Actually, no, this should work because all of it should be 0 and this should not do anything at all. So maybe we should try this. Okay, it also works, yes, because we don't actually have any patches in here. And now we need function return. And what function return will do is it will create one of those after the move, obviously. So function return patch star return patch is make jump of let's rename it to builder for consistency, because everywhere else it's already a builder. It's a bit strange that here it's not. So we say make jump of builder. Actually, not like this. This should be temp allocate function return patch, and now star return patch is const function return patch. Patch is this, and then next is builder return patch list, and now we update this patch list to return patch. Pretty standard linked list, nothing really fancy. And it compiles, and now the moment of truth, because I have no idea if it will actually work from the first start, but we can try. Wow, it actually does work, which is really interesting. So before we check out assembly to make sure it's not crazy, we try to get rid of this stuff and this stuff and this stuff. Okay. And let's run the tests again. And it still works. So that's very, very nice. Let me move the make is non-zero to here, to the test, as with all other stuff that we did before we check in the assembly for how it looks like. Is non-zero. Fine. Let's call it is non-zero value like it was before. Still builds. Let's try it out. It's great. I guess we should look at the assembly. And see how it works. The one that we are looking at right now is where is it? Yes, this one. And in particular, we are interested in the call itself so that we can easily jump to the assembly. Let's look at this assembly, step in, step here, and look at what we have. So let's try to read through it and see if it all makes sense. So this is stack reservation. This is good. This is we are checking if this is 0. These instructions, these 3 instructions is compare itself, and this is if. And then if it is equal, we do move to EX, which is the return value, and jump to 40. And 40 is exactly the kind of the epilogue of the function which we wanted. And this is the jump that is sort of completely unnecessary, but this is something we can fix up later. This is okay for now because the consistency and stability wins over performance, at least at this particular moment. Good. Unfortunately, I now have to run, but I think we made a really good progress, and I will try to convert the remaining stuff off screen and only will leave it alone if there is something that we did not implement yet for later times. Maybe I will do another video that will deal with call macro, because I think it's nice to show off how the variadic macros work, even though it's a bit mind-bending. And then there's probably going to be other stuff around structs that we have to take care of. But that's it for today. Thank you very much for watching, and hopefully see you next time.